Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X researcher and professional physicist, and today I'd like to discuss with you one of my latest articles, which is entitled Further Observational Evidence of Brown Dwarf Stars Close to the Sun. And it starts, although accepted theory tells us that it is impossible for brown dwarf stars to have entered the solar system and to have accumulated around our sun, this is exactly what observational evidence is showing us has happened and continues to happen. Current physics thought says that theory must be correct, and so we must ignore observations. This is completely wrong. This builds a completely erroneous idea of our universe. Physics is the study of the laws of the universe, and our understanding of these laws is supposed to advance through observation, leading to revision of current theory and to new theory. In this article, I show further evidence of the fact that these objects are here. These objects are mostly dark, but some have started emitting light from their gaseous envelopes and are therefore visible in visible light and X-rays. So we start with figure 1, which is an image provided by Stereo A. It's a Core 2 image from July 24, 2017, and we see various objects in this image. For instance, here is one such object. It has a dark core, and we can clearly see a cloud-like structure around it. This is the characteristic shape of a brown dwarf star. Only a brown dwarf star is a core which was the core of what was once a main sequence star, and the cloud, the ionized cloud, can only be there as a result of a star going through the red giant phase and turning into a white dwarf. When it goes through the red giant phase, it starts losing the outer layers of gas that belongs on the surface of the star. And it does this because the energy drops and the ability to ionize and to generate a magnetic and a gravitational field decreases as the star's internal energy decreases. So this object is indicated by this blue arrow, and here are two other objects. They look like two little dots, but they are having plasma ejections in the direction of the sun. And planets do not have plasma ejections because planets do not have glowing plasma in order to produce ejections. Only stars can do this. So it is likely that these objects are very small brown dwarf stars. As you can see, they are much smaller than this one here. So in the next image, we have what looks like an explosion, but if it is an explosion, it has to be associated to an object. An explosion does not occur in outer space without there being an object that is the source of that explosion. In fact, this irregular shape suggests that this is a cloud of ionized gas. The cloud of ionized gas is therefore associated to a star. These stars have cores and are surrounded by a cloud of ionized gas. We see strong light emission coming from this object. We see that the center seems to be a lot brighter than the edges, but all of it looks like a cloud because of its irregular shape. So this would be associated with another brown dwarf star. However, this one, we see that towards the center, it is brighter. So what happens with these brown dwarf stars is when they come into the solar system, they are completely dark, they are cool, they only emit infrared radiation. And as they spend more time close to the sun, they absorb some of the sun's internal energy, and therefore their own internal energy increases. As this increases, they are then able to ionize the cloud of gas. Well, they are surrounded first of all by an envelope. It's an ionized gas envelope. Well, it's ionized by the star's internal energy. So the envelope starts having plasma discharges. And this envelope is shaped like a thick ring because this is the structure that white dwarf stars have. And brown dwarf stars are basically cooled down white dwarf stars. So this envelope is around the core and it forms a thick ring. So that means that on two sides you will be able to see the core, which is initially dark, and then as the cloud becomes more and more ionized, the star is able to produce plasma discharges within the cloud, and that then leads to the emission of visible light photons, so the cloud becomes visible. So what we saw here in the first image, this is the core that we see through that hole in the cloud, because this is then ring-shaped, and this would be the side of the ring through which we can see the core. So it's cylindrical shaped, and then we have the cloud. The cloud starts emitting light, which is why it's visible even in the sun's outer corona. But the inside is dark. However, as these stars spend more and more time in the solar system, they accumulate more and more internal energy, which they absorb from the sun. And therefore, eventually, they are able to emit light from the core, from the surface of the core, because the electrical potential energy is associated to having the fusion reactions, or they power, at least partially power, the fusion reactions that then will occur on the surface of the core. And these are, of course, cold fusion reactions. Now, that image was an image that I obtained from before these images are manipulated, because the last 2 days of images are usually not manipulated yet. They are pixelated sometimes, but a lot of structure is visible in these images. However, once they go through whatever NASA deems necessary, then they become, this is what they look like. As you can see, a lot of the structure is no longer there. And even this bright light that was visible in the image, this is exactly the same image. It's just, it's from July 24th, 2017 at 1809. And as you can see, this image is exactly from exactly the same time. It has exactly the same timestamp. However, this image was obtained before the manipulation was done, and this image was obtained after the manipulation was done. And as you can see, the manipulation leads to a lot of the structures being much less obvious. And that shows that this is one of the ways that these objects are hidden from us. In this image, this is again another image that has not been manipulated yet. This is from July 25th, 2017, from 2139. And what we see is some of the structures in here have the characteristics of brown dwarf stars. As you see, there's a dark center and there's a ring-shaped cloud that is emitting some light. That's why it looks lighter, surrounding the core. So this is the characteristic shape of brown dwarf stars. And it therefore seems that there may be quite a few more in the sun's outer corona. Then the next image is an SDO image from July 23rd, 2017. This is an X-ray image, so it's in the 9.4 nanometer wavelength. It's from 623 UTC. And as you can see, this is the sun, this is the sun's corona, and what we see in the sun's corona is lots of these objects, characterized again by a dark core and a cloud, which is basically the envelope surrounding the core. These are therefore small brown dwarf stars. The Earth is here. As you can see, it's not very clear because of the HV in front, but these objects are basically around the same size as the Earth. These are small objects. Now, don't forget that white dwarfs are about the same size as the Earth. So these objects are about the same size as white dwarf stars. They're just a lot cooler. And since these objects actually seem to increase in size as they age, and the reason for that seems to be that their ability to generate fields, including the magnetic field. And this is why these brown dwarf stars have to go into the sun's corona to absorb plasma from the sun, because the magnetic fields are not as strong as that of white dwarfs. So it seems that these objects' magnetic fields decrease as the objects age. And as the magnetic fields decrease, it seems that the gravitational field they generate also decreases. And therefore, these objects start to grow as that energy decreases more and more, or as they age. And this is also why we have them with so many different sizes. We have Earth-sized brown dwarf stars, and we have very large. We found the blue brown dwarf, for instance, was about 1/3 of the size of the sun. And we are about to see one that is even larger than that. So the mass they generate decreases as they age. That means that these small ones have higher magnetic fields and higher gravitational fields, and therefore higher mass or density than the larger ones. And that means that the effect on the sun may therefore be stronger than the larger ones. Also, these objects are still strongly able to hold on to their clouds of ionized gas. When they get older, the magnetic field they generate is weaker, and so they may not be able to absorb energy from the sun as well, because they do so through a magnetic interaction. And then because their gravitational field decreases, their mass decreases. And so they're not as able to hold on to their clouds of ionized gas, and they start losing them. And this is what was happening with the blue brown dwarf. Now, the next object that we see here is a very large object indeed, which was made apparent by a CME that occurred on the sun on July 23rd. Now, the way we see this object, and it's seen here in black and white, and why I think it's a solid object is because we see both edges. We see an edge, a clearly defined edge on the right-hand side, and a clearly defined edge on the left-hand side. And if I then draw a circle through where the edge of the object is, this would be about its size. And as you can see, it's about the same size or even larger than the sun. The sun size is indicated by this white circle. Now here we see a close-up of that image. It doesn't have the ring. As you can see, it looks like a solid object there because of the defined edge. Now, these little objects that we see here are not background stars. These, if we look at them very carefully, actually have structure and are three-dimensional. There's no way that background stars, which are out there, some of them may actually be other galaxies, could possibly have this kind of structure. These are debris in front of the object. And some of this debris could be coming from the object itself, or it could be that these are because these are about Earth-sized. These could be some of the smaller brown dwarf stars that we know are in the sun's corona and may have been ejected with the CME. So, or they may even have two sources. This object may have had some of these small brown dwarf stars associated with it, or they could be part of its debris field. It's a cloud of ionized gas and debris. Or they could have come directly from the sun's corona and ejected as the sun produced its CME. Now, it's impossible for a CME to have a perfectly spherical shape in it unless there is a solid spherical object producing such a shape. So as the object is seen in, and we are going to see that here because it's seen in several frames as well as the clear shape that we saw in the 6 o'clock image. So this one is from 548. This is the same image, but here I drew again the object. It's exactly the same size as the object in the 6 UTC image. And this is from the 612 image. Again, we can see the outline of the object, although it's not as clear as in the 6 image, but it again is exactly the same size. Also, we see that the circle is closer to the sun here and further away from the sun. So it looks like the object is pushed or it moves away from the sun as the CME progresses. So, in fact, it could be, this is actually suggestive of the fact that the CME pushed this object away, and therefore the CME may actually have been caused by the presence of this object. Because if this is indeed a brown dwarf star, and it's very likely that it is, I don't think it is a normal star because it's not emitting bright light like we would expect a main sequence star to emit. This object is dark, and we see it because the CME is ejected in its direction, and it makes its edges and outline visible. So it looks like, or this is suggestive that the CME may actually have been caused by this object. And how does this happen? Because these objects have high magnetic fields, and these magnetic fields are stronger than the sun. So the presence of this magnetic field would destabilize the sun's magnetic field, which could then produce this kind of CME, as the particles are actually pushed and accelerated away from the sun and towards this object. And that in turn could push the object away. We have to remember that this large object produces the strong magnetic field, but it's large. I know that people will say, how is it possible that we can have such a large object close to the sun? And well, according to accepted theory, the presence of such a large, massive object close to the sun should be extremely disruptive to the whole solar system. However, these observations I have been making for months have suggested to me that the gravitational interaction is not the primary driving force in planetary systems, and in fact, most probably in the whole universe. The primary forces seem to be the electric and the magnetic interactions. These objects interact with each other through their magnetic fields. They draw energy and plasma from the sun through the magnetic interaction they have with the sun. Also, it seems that these objects are attracted to the sun. This is why there are so many in the sun's corona. So to me, this suggests that the strong force is acting on an astronomical scale, and that these objects are like protons and neutrons in the nucleus. So stars, when they come together, they can congregate at the nucleus of a planetary system, just like protons and neutrons congregate in the nucleus of an atom. And they are attracted to each other, even though protons are positive, and they still experience a repulsive force due to the electrostatic interaction between protons. They are also attracted to each other due to the strong force. And therefore, this suggests to me that these objects, these stars, and some of them are very old stars that have gone through the red giant and the white dwarf stage. In fact, just about every single one of them are these kind of objects. Some of them, I think, are rejuvenated brown dwarf stars, where they have been able to absorb enough energy to start emitting light from their cores. So in conclusion, the evidence that there are brown dwarf stars close to the sun keeps mounting. Any physicist or anyone who has seriously studied physics insists that accepted theory states that it is impossible for these objects to be close to the sun does not understand what physics is all about. Physics was initially driven by observation and should continue to be driven by observation. Observation reveals that these objects are close to the sun. Ignoring observational evidence leads to the problem of failing to identify a falsified theory, such as the Big Bang model, and thus continuing to do and publish research based on the fact that the big model is a good model. This then becomes a case of the blind leading the blind, and to research that leads away from the understanding of the true laws of the universe. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.